Hey guys, welcome back. This is Professor Hank, and in this video we're going to talk about performing calculations in Python, right? So what we want to look at here is basically, how do you add things together? How do you do division, right? What types of division can you do? What are the order of operations? What happens if you try to, add two different numbers that are different types of data? What if you try to add a float and an integer, for example, okay? So we're going to talk about that briefly. Going to give you an overview here at the beginning, and then as usual, we're going to dig into a programming example. Okay, so let's go ahead and get started. So, when you're doing some arithmetic, math, whatever, you want to do addition, subtraction, multiplication, division, and all that kind of stuff. Obviously you can do that in a programming language. Python's no different. So, what are your math operators, right? So, grade school you're taught, there's the plus symbol, there's the minus for subtraction. You make an X for multiplication, right? So you have operators in Python for, performing your calculations. But, some of them are going to be a little bit different than what you're used to because of the fact that, for example, for multiplication, X, well, that's the character X. So you can't use that as part of a mathematical expression. Okay, so mathematical expression is basically, a code that you write that's part of a statement that does some kind of math. Okay, just so you know, just an FYI. Now, what are the operators that you have? Well, let me go through these with you really briefly, right? So take a look at these guys right here, and what you have is plus for addition. You're used to that. You get a dash, a minus for subtraction. You're used to that. Now, instead of an X for multiplication, you use this asterisk, right? Because X by itself is a valid identifier. It's a valid variable name, right? So we need to use something else. Okay, so what you use commonly in Python and C-type languages is an asterisk for that. And we got two types of division, okay? So we'll talk about that more here in a second, but we've got floating point division, which is /, and you've got integer division, which is two // right next to each other, okay? You also have modulus division, which is a percent. I'll give you an example of that when we do the coding part. But basically, what this thing is this is, what if you want to find out the remainder of something? What's the remainder of 3 divided by 2, right? Well, 2 divides 3 once with 1 left over. That's what modulus division is for, to find out what that remainder is. Okay, so Python also provides an exponentiation operator, which is really nice, really convenient. What if you want to find 3 cubed, or c squared or something like that? Well, you've got two asterisks right next to each other for performing that operation, right, to figure that out. Okay, so when we get to the coding part, I'll show you examples of all these operators and how they're used, okay? Now notice this little caret, which shifts 6, is not an arithmetic or math operator in Python, okay? It's not a math operator. A lot of times people will hop onto online forums, or will type in text, maybe from your math classes or something, you needed some online help, email your instructor, whatever. And so you end up doing something like this to represent, 2 squared. Okay, no, 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 no. Okay, don't use this thing for arithmetic. No, 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 no. Okay, maybe I can say no one more time. No. How about no? Okay, do not use it. It's not for exponentiation. It's not to raise something to a power. That's what the double asterisk is for, okay? Now, what are operands? Little bit of a definition for you here. Here's your math operators we saw in the previous line. What are the operands? Things that go around the operators, okay? So, values or variables. So here's some examples, right? A plus B. This is a math expression. What's the operator? The plus. What are the operands? In this case, A and B. Another example. 2 times C. Here's another example. So 2 asterisk C. Okay, this is proper syntax. Okay, what's improper syntax can't do something like that, right? 2c, it's great in algebra, but not in Python, right? If you want to multiply 2 and c together, you got to use that asterisk. Okay, now this is an example of doing integer division. D double forward slashes E, right? So integer division, I'm going to talk about that here in just a second. But division, there's no, bar with the little dot on the over and under that bar on your keyboard, right? So you got to use something else for division. And so a single forward slash is for floating point division, and double forward slashes for integer division. And if you wanted, just one more example here, if you wanted to know what 2 squared was, you would type 2 asterisk asterisk 2. That is how you do exponentiation, right? Do that. Not this. Remember, I just sent you a hail of no's, right? No, 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 no. That is not 2 squared right there. Okay? This is 2 squared. Reason I'm being so, annoying about it is because people forget that all the freaking time, right? I see that mistake time and time and time and time again. So if me saying no 10 trillion times helps you remember it, well then, mission accomplished. Okay, so let's talk about 2 types of division. So you've got a forward slash for floating point division, you got 2 forward slashes for integer division. Well, what's the difference? Well, a float divided by a float is a float, right? So if I wanted to preserve decimal places, right, then I have to use this forward slash. So if I want to get a floating point number, then I'd need to use that single forward slash. So for example, 3 divided by 2, okay? Now what does that equal? Well, if I'm doing floating point division because I'm using this forward slash, that will get me, that equals 1.5, okay? But the double forward slash is for integer division, in which case your answer is going to be an integer. So 3 double forward slash 2, the answer to that is not 1.5, okay? The answer to that is 1, right? Because what happens with integer division is the answer is an integer. Integers don't have decimal places, okay? So a single forward slash, you preserve your decimal places. Double forward slash, you lose your decimal places, okay? All right, so order of operations, what does this mean? Well, let's say lock up the house. Sorry about that, Alexa was interrupting. So let's say you had a complex mathematical expression, right? You're not just limited to doing stuff like a plus b, okay? So you can do something like a plus b times c, right? Well, what goes first? Do you add a and b first, or do you multiply b times c first? Well, this is going to follow pretty much what you're used to from arithmetic, right? So in this case, a plus b times c, the b times c is evaluated first, and then that product is summed with a, right? So let me just replace those variables with some actual numbers. So what would the answer be here? Well, 5 plus 2 times 3, that answer is that you're going to do 2 times 3 first, and then you add 5 to that. So the answer to this is going to be 11, because 2 times 3 is 6, plus 5, 11. So the order of operations from top down, listed right here, parentheses, all right, that overrides the order of operations, as you probably already know, right? And you can even just include them, just to remind yourself visually that the multiplication goes first. Fine, you don't have to do that, but you can. Now, if I wanted to do the addition first, right, well, then that's a little bit more useful, right? So if I put the parentheses around the 5 plus 2, well, that 5 plus 2 is going to go before the 2 times 3. So I'm going to get a totally different answer now, right? Because 5 plus 2 goes first, that's 7. And then we do the multiplication times 3. So in that case, the answer is 21, right? So parentheses goes first, then exponentiation, right? And then you've got your multiplication and your types of division, and then finally your addition and subtraction, okay? So for example, I could do something like this: 5 times 2 cubed, right? What does that equal? Well, looking top down, multiplication, or excuse me, exponentiation has a higher precedence, or it's higher up on the hierarchy than multiplication. So we're going to do that 2 cubed first and then the multiplication. So this is equal to 5 times, well, what's 2 cubed? 8, right? So that's, your answer is going to end up being 40. Okay, now what if I did something else here? What if I added, I don't know, 3 to this and then divided that by 3? Okay, well, let's look at this example. Okay, so exponentiation still comes first, so this becomes 5 times 8, because 2 cubed is 8, plus 3 divided by 3. Okay, now what fires? Well, now you can see that I've got multiplication and division, which both have a higher precedence than addition, right? But which one goes first? Well, these have left or right associativity, which means that if they're part of the same expression, you're going to go from left to right. Okay, so the 5 times 8 happens, and that's 40, right? And then the 3 divided by 3 happens, right? And so that is 1. Okay, so then the addition comes last, and so that's going to give you your final answer of 41. Now, again, we can override the order of operations by putting things in parentheses, right? So, I don't know, let's do this, for example, right? So what that means is that the 5 times 2 goes before everything else. So now that would effectively resolve to this, 10 cubed plus 3 divided by 3. Well, then what comes next? Well, exponentiation is higher than both floating point division and addition. So 10 cubed is 1,000 plus 3 divided by 3. Well, 3 divided by 3 is 1. Oops, forgot my 0 there. Forgot my 0 there. So the division then resolves, is evaluated, and so you end up with a final answer of 1001. Okay, so order of operations, they flow just as you would expect. It's just a little bit weird because we got these different operators here, but parentheses, then exponentiation, then multiplication, division, then addition and subtraction. Okay, so last thing here, and then we'll write ourselves a program to see some of this stuff play out. Give you some examples. Mixing types. Okay, so what happens if you try to add 5 plus 2, 2 integers, right? Or a plus b, where a and b are both assigned integers. Well, then the answer you're going to get is going to be an integer. So 5 plus 2 is equal to 7, right? What if you add a float and a float? Okay, well then the answer is going to be 3.3, right? It's going to be a float. An int plus an int is an int. A float plus a float is a float. But what if you have a mixed type expression like this last example here? What if I try to add 5.1 plus 2? Okay, what's going to be the answer? Well, it's going to be what you would expect. The Python interpreter temporarily treats 2 as if it were 2.0. And so by doing that, the integer becomes, I guess you could say, promoted to a float or temporarily changed into a float. So that way you end up with the answer 7.1, which is probably what you're expecting, right? The designers of Python didn't have to do that. They could have made it to where a float plus an int is an int, right? So if that was the case, and you had something that looked like 5.2 plus 2, well then the answer would have been just 7 then, because if a float plus an int was an int, well, you'd lose those decimal places, right? So to preserve the decimal places, this was the design decision. A float plus an int is a float. 2, in the case of my example expression here, gets treated as if it were 2.0, and so then you end up with a float as your final answer. All right, so let's fire up idle and do some examples, right? So what were the different operators that we have access to? Addition, subtraction, multiplication, floating point division, integer division, modulus division, exponentiation. Okay, so let's go through and see examples of all of that, right? So how about I just ask the user I'll go ahead and ask the user for a couple integers. Okay, and then we'll go through and we'll see what the results are of all those operators. Okay, so I'll ask the user for number. Okay, and I'm going to use input to do that. But remember, input returns whatever the user types as a string, right? So what's it mean to divide one string by another? I have no idea. What does that even mean? So we got to convert whatever the input function returns into an integer before we assign it to our variable, to our name here, num1. Okay, so enter a number. Okay, so we'll throw that in there, and then we'll do a similar thing for a second variable. Okay, and then we'll just print out all these answers. We'll figure out what all these answers are. Okay, so we'll add them together first. Okay, so let's see here. So we'll just print them out, right? Num1 plus num2. Okay, and then we'll show the difference. Num1 minus num2. Okay, and then we'll show the product. Num1 times num2. All right, and then we'll have our floating point division, right? And then we'll have our integer division, okay? And then we'll have our modulus division, num1 modulus num2. And then we'll do exponentiation, right? We'll do power, so we'll raise one to the power of the other, okay? So we'll have it all one right after the other. Okay, so let's go ahead and run that and see what we get. Okay, so the first number I'll type in will be 3, and the second number I type in will be 2. Okay, now let's examine the answers, okay, and see what happened. Okay, so typed in 3 and 2. So the first print statement happened. 3 plus 2 is 5, and so that's our first piece of output. The second print statement, 3 minus 2 is 1, and so that's our answer right there. The third print statement, 3 times 2 is 6. There's our output right there. Now floating point division, okay, 3 divided by 2, 1.5, as you're used to, 1.5. So there's the 1.5. Now look at this. This is integer division. Integer division. 3 divided by 2, when you're doing integer division, is not 1.5, right? The result of this operator is an integer. So the answer is 1. There are no decimal places as a result of doing integer division. Okay? All right, so let's move on to modulus. Now what's modulus do? This is 3 modulus 2. So modulus gives you the remainder. Gives the remainder, okay? And this guy right here gives you an integer, right? So no decimal places. And then this right here is floating point division, right? And then this is integer division. So just some reminders here in the comments. Okay, so if this right here, if modulus gives remainder, well, what's 3 modulus 2 then? Well, if I divide 3 by 2, 2 divides 3 once with 1 left over, with a remainder of 1. So there we go, right? Now, very last thing, exponentiation. 3 and 2, right? 3 was assigned to num1, and then 2 was assigned to num2. Well, what's 3 raised to the second power? 9. It's 3 squared. Just like that. Just right there, okay? So I mean that's it. I mean that's how those things work. I mean they work as simple as you would think. Let me just give you a few more examples I'll make up off the top of my head here. Let's see here. I'll go ahead and comment all that stuff out just so the output won't interfere. All right. So and I could also do something like this. I could say let's see, I'll make something up here. So I'll say answer equals 8 squared, okay? And then I'll print answer. Okay, so now if I run this, what are we going to see? 64. So you can see that my expression doesn't have to be variables, okay? I could also say, answer is equal to, equal to answer plus 3. Okay, so what's this going to do? Okay, then I'll print out that answer. Well, this line right here is going to execute first, right? So that's going to be 64. So answer is going to have 64 in it. We'll print that out. But then here, the right side, right, of the assignment statement, that executes first. So we're adding what's in answer, which was 64, and 3. So that's going to be 67. And then we assign that to answer over here, right? So then that 64 that was an answer is replaced, and we're going to print out answer, so which is going to be 67. Okay, so let's go ahead and run it just to show you. Right, so there's 64 and 67. Now remember, right, what went into answer here? Answer equals 64. Why? Because 8 squared, right? But here we took what was in answer, and we already know from this line it was 64. We took what was in answer, 64, and then added 3 to it. So that became 67, which we then assigned to answer. Okay, so answer after this line is no longer referencing 64, it's referencing 67. Okay, and so that's why you see the output that you do here. Okay, now I could also do something like this. I could say A equals 3, B equals 2, and then I could do something like this. C equals A plus B times 3. Modulus 2 and minus 1, something like that. So then I'll print out C. Okay, well, what's the answer going to be? Okay, well, what's going to happen is that, remember the order of operations. Okay, multiplication and division and modulus all happen before addition and subtraction. Okay, so and they're left to right associative. So what that means is that this multiplication is going to happen first, followed by this modulus, right? And then the answer of all of that will be added to whatever's in A, and then the answer of all of that will have 1 subtracted from it. And then that entire mess, that result will be assigned to C, and then we'll print out the contents of C, right? So let's go ahead and run it. So there's our answer 2, and does that make sense? Well, let's do the math, right? Let's trace through it. So A plus B, okay, so what's in A and B? Well, in these first 2 lines up here, we assigned 3 to A and we assigned 2 to B. So this is really like saying 3 plus 2 times 3 modulus 2 minus 1, okay? Now what resolves first? The multiplication. So 3 plus 6 modulus 2 minus 1, right? So then what resolves next? Well, 6 modulus 2. So if you divide 6 by 2, right, 2 divides 6 3 times with nothing left over, right? So 6 modulus 2 is 0. So then we add 3 plus 0, which is 3, right? And then finally the minus 1 happens, and so that leaves us with 2, okay? All right, do I want to do any other examples here for you? Yeah, let's assign to, let's reassign to A 1.5, and then let's reassign, we'll leave B as 2, okay? So then we'll go ahead and add them together. C equals A plus B, and then we'll print C, okay? And then we'll run that. See, the answer is 3.5. Why? Okay, well, as soon as we have A equals 1.5, that 3 that was in A, right, that's replaced, right? It's now, A now has 1.5 assigned to it, okay? Now, once we get down to C equals A plus B, well, what we really are doing here is we're putting or assigning to C, we're overriding that 2 that was assigned to it with this line. We're overriding that with A plus B. Well, what's A? 1.5. Well, what's B? Well, B didn't change, right? So we're adding 1.5 plus 2 Now remember, mixed types, that 2 gets treated as if it were 2.0, so that way float plus float equals float. So then the answer, if you add 1.5 and 2.0 together, is 3.5. So then that 3.5 was assigned to C, replacing the 2 that was in C. And so then when we print C, we see the 3.5 here. Okay. So that's basically it, right? And you can make your arithmetic expressions as complex as you need them to be. So let's say that I wanted to, I'll go ahead and comment all this stuff out, just to get it out of the way. Let's see here. So comment out region. I should just remember it's all 3 to do that, but whatever. So let's say that I wanted to write a program that was going to compute, find the slope for a line, right? Well, what's the slope for a line? Okay, it's m equals, what is it? y1 minus y0 divided by x1 minus x0, something like that, right? Well, you can't write it exactly like that in code, right? You only have ASCII text here. So, you can't have a bar, you can't do subscripts, all that kind of stuff. So it's up to you as a programmer to convert those formulas that you may be used to in more of an algebraic notation into something that's syntactically correct for the language that you're programming in. So, I might have to do something like this. I might have to say, well, the formula is, y1 minus y0, right? And then I have to divide that by x1 minus x0, right? So I have to rewrite it. And you'll notice that I'm using parentheses here, and this is very important because without those parentheses, remember order of operations, division has a higher precedence than subtraction does, right? So without those parentheses, this division happens first, which is wrong, right? I have to divide the difference of the numerator by the difference in the denominator here, right? The difference of the values that make up the denominator. So, it's up to you to make sure that you write things syntactically correct if you're trying to convert algebra into something, right? So, I might ask the user, oh, no, I want to type all that. Yeah, I'll type it out. I might have to ask them for y, x0 and y0, right? So I'll say x0, right? And I'll say, give me x0. Int input, enter x0. Okay, and then I'm gonna have to do the same thing for, y0 for the first point. Okay. And then I'll do the same thing for the second point, right, on the graph. Okay. Okay, I'm going to do that, and then I'm going to calculate. I'm going to get the input, and all programs work this way, right? You get the input, then you have to process it in some way. Okay, in this case, I'm going to find that slope using that formula I just told you about. Make sure I'm very careful to write it correctly, and then you provide some output. Okay, so then I'll print the slope is m. Okay, so let's go ahead and test it. Okay, so I'll enter for x0. So the first point will be 1, 2, right? So for the second point, it'll be 4, 3, right? So there's my slope, right? So the slope is 0.333333 repeating, okay? All right, so I think that's everything that I wanted to talk about here. So just keep in mind, what are your operators? There they are, right? I showed you examples of all of those things. Make sure that you keep in mind the order of operations, when you're constructing your mathematical expressions. Remember, you can use any combination of variables or the rules that you want. You can make these mathematical expressions as complex or as simple as they need to be. Good variable names are better, than what I used here, just by throwing in A and B. But that's just for example, I use those names. And also keep in mind, you have to be very careful when converting formulas from algebra, for example, into actual syntactically correct Python code. Keeping in mind what those orders of operations are. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up. And if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.